In this gravity inversion exercise, I'm going to show you how to use constrained inversion using standard gravity inversion. In this data set, we have a starting basin model shown in brown here. We have the Bugey gravity data shown in black. We have the initial model response shown in brown, and a regional which has been determined across the area shown in pink. Start the inversion process. Right-click in the background area to bring up the tools bar. Select inversion for gravity. This is standard inversion, not joint inversion. We look at the configuration parameters. We don't need to change anything. I'll turn off the noise from the beep as it will operate fairly frequently. We'll bring up the free parameter list. And for this type of inversion, I'm going to set a low threshold for the RMS, about 0.5% for convergence criteria. Now, the first thing I want to do is free up Z and possibly X. So I'm going to set the tolerance limits for that inversion process. If I click on X, I'm going to allow it to move plus or minus 500 meters from its current position. That's for each vertex. And for the Z vertices, I'm going to allow them to move up and down by, say, 300 meters. We apply those settings, close it, and if we click on the list box button, we'll see all these parameters are free. The range for the parameters has been set here, the min and max. We can change those manually. I'm going to show you how to do that graphically. For the moment, we're going to leave the X vertices off and just use Z as free. We don't want the two end vertices to move. Those are Z1 and Z2. The other vertices, these, we're going to allow them to move up and down. Now we have a nominal X range set for these boxes, but we're only allowing them to move in Z. So we're really now ready to run just by freeing up Z. We're not going to allow the regional change because that has been preset. So let's run the inversion to start. Converges fairly quickly as far as it can go because it will have reached some hard limits. We just drag the mouse cursor down over the free. We can see that the vertices have reached hard limits for the constraint boxes. Now if we want, we can move those boxes down to allow more freedom and what we believe is geologically reasonable. We mightn't allow that one to move quite as much. So we've done that graphically. We're ready now to run the next stage. Click on Run Again. And we've got a fairly good match here. Just let's have a look at the boxes. We didn't get much movement in Z for this one, but we might want to allow that one to vary a little in the horizontal direction. That parameter is the X7 parameter. So we're going to free that one up in X, and we're going to keep the other Z's free. Run the inversion again. Now we can see we've reached a hard limit. We could actually shift the box horizontally. Now you can also change the range and increase the width for an individual one to give it more freedom to move. Run the inversion again. Let's just check the boxes again. Now that's about as good as we want to get. We could start finessing the little bump here by adding some more vertices, but we'll leave it at this particular stage of inversion. It's quite a good match. We've got about 1% RMS. Close down that window. When we close inversion and save the session file, all those constraints will be remembered. That's a new feature in release 15, and you can come back into a session. If it's a big session, you can come in time after time and rerun it.